Good afternoon. Today's lecture topic is the remote sensing and geographical information system for the coastal and the ocean sciences. First, let us see what do we understand by coastal zone. Coastal zone is the transitional area between land and the sea. That means this is the area but not a line. When we talk about the line, basically we talk about the land and water boundary. But here when we talk about the coastal zone, it will be an area in between land and the sea. It is a band rather than a line. So that means if in a GIS system, if we digitize the coastal zone, it will come as a polygon. But when land and water boundary is concerned, it will come as a arc or polyline. Okay, that is the difference between the coastal line or the land water boundary or the coastal zone. And the width of this band or this coastal zone is varies from place to place and is determined by the interaction of the marine and the terrestrial or the land processes. That means everywhere the width of the coastal zone is not same. It depends on how your marine processes and how the terrestrial processes interacts with each other and which one is more stronger. Like if I give you example, like if the marine process is very strong enough, so they will push the coastal zone far deep into inside the land, and vice versa. If the terrestrial processes are very strong, the coastal zone will be very narrow. This zone is occupying less than 18% of the Earth's land surface. That means the area is not very huge. Only only 10%, only 40% of the 1 million kilometer coastline is accessible. That means in the world, total length of the coastline is around 1 million kilometer. Out of this, only 40% is accessible and temperate enough to be habitable. That means it can human being can stay over there, but it accommodates around 60% of the world population. That means area is very less, that the population is very high. That means density of the population will be tremendously high in the coastal zone. At the same time, there will be exploitation of the coastal resources, and that is why we talk about the coastal zone management. That is what is mainly the today's lecture topic. So, why we basically need to study the coastal zone? As I told you, it is around 18% of the surface of the globe. Within this 18% of the surface of the globe, 60% of the world population are living. That is most important. Two-thirds of the major cities of the world are lying in the coastal zone. That if you see our country, except Delhi, like Calcutta, Kolkata, Mumbai, Chennai, they are all lying in the coastal zone. Along with these metros, there are various other cities like Vizag. So they are also lying in the coastal zone. Um, Population density, as it is very clear from the earlier two bullets, that area is less but the total population number is very high. That is why the population density is 6 times higher than the non-coastal areas. Another most important thing is the in the coastal zone 90% of the world fish catch comes. That means coastal zone is very productive. The food usually gets their fishes usually get their food in the coastal water because the concentration of the phytoplanktons are very high, and these phytoplanktons are being born from the land by the various kinds of rivers who are meeting in the coastal zone. That's very important. So it has been seen that 90% of the wild fish catch are coming from the coastal water itself. And there are various sensors called ocean color sensor, which tells you about the amount of phytoplankton, which are microscopic plant who used to be taken by the fishes for their food. So their concentration, if you see, if you map any coastal area ocean color image for the phytoplankton concentration, if you see, the concentration of the chlorophyll is very high in the coastal water, but when you go deep away from the coast in open ocean, the concentration of chlorophyll is less. That is mainly because of the rivers which are meeting in the coast. And as I told you that part of the land area is under the coast and part of the ocean is also under the coast, and when ocean is concerned, it is around 8% of the ocean surface comes under the coastal water. Lots of rivers are bringing lot of sediments and they are dumping in the coastal water. So 75 to 80% of the global sink of the suspended river load are happening in the coastal zone, and that is why coastal water you can see in maximum places it is very turbid, except the places like where corals are there, like Andaman Nicobar, Lakshadweep, Gulf of Manna. Those places water is very clear, but the rest of the areas, if you see the coastal zone, the water is highly turbid. 90% of the global sedimentary mineralization from the geological point of view, like igneous mineralization, the mineralization by the metamorphic processes, mineralization by the sedimentary processes, 90% of the global sedimentary mineralization are happening in the coastal area. So coast is a vital importance of the humanity that we will see in the subsequent slides. It gives you everything for the human being to live. That is why the people love to be in the coast, and our prehistoric times, basically our civilization started from the coast. That's why the population is so high. So civilization started from the coast because earlier there was no, you know, rail network, no your air, there was no bus routes. So there was only one way of transportation, that is a voyage. So all the big explorers like Jab Charnak, like Vasco da Gama, they came by ships. They discovered various countries. Columbus discovered America. Vasco da Gama came India. So from the very prehistoric time, people started living in the coast. So it's very important from the humanity point of view. But at the same time, it is very fragile ecosystem. So if you disturb one part of the coastal ecosystem, it is going to be disturb the rest part as well. So if you cut the mangroves, the entire coastal zone is going to be coastal ecosystem is going to be disturbed. It's a zone of rapid transition, gradient, and the variation. So lots of parameters varies in the coast. Even the water itself, like if you go air from the coast, the temperature varies. If you go the depth wise, the pressure will vary, the temperature will vary, the density will vary. So there are a lot of transition, gradients, and the variations. So it is very difficult to boundaries because it is a very dynamic, highly dynamic region. There is high tide, there is low tide. So it is very difficult to put a constant boundary. This is the coastal zone because it's always, with time the water comes and goes because of the attraction of the sun and the moon. We call it high tide, low tide, spring tide, nip tide. So it's very dynamic area, and it is as lots of population is living. So everybody will be living their livelihood in the coastal area. So the coastal zone is subject to multiple uses. So like tourists have their importance in the coastal zone. We have lot of industry in the coastal zone. Lots of hotels are coming up in the coastal zone. So there are a lot of activities in the coastal zone. In the next slide, I will show you the so many various kinds of activities. You see, this is a schematic diagram. Industries are coming up in the coast. Lot of quarrying activities, sand extraction and mining is happening. Oil extraction in the coast. A lot of agriculture activity, forest areas, urban areas are coming up along the coast. Lots of tourism activity, fish farming, military activities, defense, naval activities are in the coast. So those things are all happening in the coastal area. Lots of erosion control, dredging is happening in the coast to get the navigational depth. Dumping materials, lot of waste dumping, and all those things are happening in the coastal area. So there are so much of activities are happening in the coastal area, and all those activities have certain kind of negative impact in the coastal ecology. So we need to study them very critically because they are all intertwined with each other, and we need to see how there can be a sustainable development of the coastal resources along the coastal zone, and where remote sensing has a lot of role to play with. So basically, the in the coast where research is concerned, we have the intensive agriculture, various kinds of fruits and vegetables, like aquaculture, artificial fishing, lots of other fisheries activity. Um, Exploitation of minerals is happening in the in the coast. Oil refinery, they are offshore and there are onshore oil refineries. The sand mining, the salt extraction, other minerals both offshore and the onshore. Like nowadays we talk about the manganese nodules in the offshore area. Lots of industrial activities like shipping activities, the ship building, ship maintenance, ship breaking, various kinds of oil refineries activities are happening in the coast. Fish and the marine resource processing. Tourism is one of the important activities along the coast. There are, because the coast, few areas of the coast are very pristine, white sandy beaches, which attracts the tourist very much. Like let's say example of the Goa coast area, Andaman coastal area, Andaman Nicobar coastal area. Lots of tourists they throng and they try to pass their time in the coastal area. There are beaches, swimming activities, sailing, ecotourism. Lots of infrastructure activities are happening in the coast. New harbors are coming up for the national development. Lots of pipeline, canals, road are going through the coastal area. Transport, navigation, and the communication. and when there are coastal erosions, we try to control the erosion or try to hinder the erosional activity by reinforcement of the coast through like seawall, through breakwater, to various kinds of groins. So there are the various kinds of infrastructure activity along the coast are happening. Also, above all, because few coastal area is a boundary with other countries, like we have an international boundary with Pakistan along the Gulf of Kutch, we have a boundary with the Bangladesh in the West Bengal coast. So those are the very important areas, coastal area, where lots of activities pertaining to border defense, naval activities. Like Wheeler Island, which we test our missiles over from there. So there are a lot of activities that are happening when defense activities is concerned. So if you try to summarize the coastal zone, you can see what are the major highlights. It's a high population density, high degree of urbanization are happening in the coastal area. It's a fragile and complex ecosystem, as I told you. A lot of important habitats are there in the coast. High density of the economic activities, that schematic diagram you might have seen by now. High density of the economic activities and infrastructure activities are coming up in the coast. And also definitely when there are lots of activities, there will be conflict and competition for the resources, land, marine and the water. There is definitely conflicts and there will be competition of the resources. Over exploitation, because so many activities are coming up, so many people are living, but resources are fixed. So that means there will be over exploitation of the resources, which is a major concern for the coastal zone. And because of all this, because of dumping of the nuclear waste, dumping of the thermal waste, dumping of the industrial waste, so they all pollute the environment, coastal environment. So pollution of the environment is one of the major factor for the coastal zone, which causes the degradation of the natural environment, and it causes loss of biodiversity and the natural habitats in the coastal area. Few coastal area we have seen there will be increased erosion and loss of protection against the sea and the ocean. So we lose the land, and few areas it has been seen some industry has come up, and because of the erosional activity, the entire industry activity has been stopped, and lots of money has been wasted, because unless until you study the future, how the coast is going to behave, whether this area is going to be eroded or going to be deposited, so accordingly your activity you should plan. So those things is another important. And because of all those things, there will be a increase in the social inequality and the poverty. So the people who are coming, who are setting up a hotel, and people who are coming from outside mainly, so but they don't give job to the local people, so that is the one of the major hindrance for the coastal development, I will say. Because of this, like the people who are earning their bread and butter by the fishing activities, nowadays there are hotels are coming up and other activities happening, so they leave their parental, how they earn their bread and butter, and they leave their parental house or coastal hamlets, and they go to towns and cities to earn their bread and butter. So this is why there will be inequality is increasing, poverty is increasing, and that is why there will be a huge role of the sociologist or the anthropologist. If you want to implement a very effective coastal zone management plan for the overall development of any coastal area, you need to understand the society, you need to understand the local people what they want. Without considering the local people objective, a suitable coastal zone management plan cannot be implemented in any coastal area. That is very important, and we should keep it in mind. So what is basically a coastal zone management? Basically, if you see the actual definition, coastal zone management involves the planning and organization of the development processes and control the activity of the coastal areas, aiming at sustainable use of the natural resources of the coastal zone. So that's very important, because nowadays we talk a lot about the sustainable use. That means you can use the resources, but you should not destroy them, but particularly you should keep the resources for your future generations, so that they can also come and use the resources in future. So that is what the major purpose of the coastal zone management nowadays we talk about, and that is why you need to do planning, because you cannot say that you cannot do any activities in the coast, because for like setting up a harbor or the port or defense activities, naval activities, laying up the canals, offshore onshore mining, they are very important for the national development. You cannot stop them, but you have to see how the development process can take place, so that the effect of the coastal resources, the negative effect particularly, will be minimized, and that there will be sustainable use of the resources. That is the basic purpose of the coastal zone management. So you need various, if you want to plan a coastal zone management, so you need various kinds of information, and those information basically are very diverse because they are coming from the various branches of the subject. Like in a coastal zone, basically, you know, geologist will give the idea about the coastal hazard and other thing. There will be soil scientists, there will be foresters, there will be anthropologists or sociologists. So there are so many branches of subject are involved to implement a suitable coastal zone management plan. So that's why you need say various kinds of data. So data will be very diverse. Okay. Therefore, if you want to set up a coastal zone management information system, we call it CMIS, coastal zone management information system. It has to be an open system and able to combine different kinds of data that can be extended to separate levels of detail. So it cannot be a closed system. It has to be an open system where the various kinds of data from the various branches can come and incorporate it in your coastal zone management information system based on the area. So that's why we used to tell there is no coastal zone manager as such, because most of the times the coastal zone management is the responsibility of the different government organizations. So coastal zone management involves several disciplines. It involves hydrology, soil and water conservation, environmental expertise, forestry, agroeconomy, physical planners, sociology or anthropologist, economist. So and nobody can be master of all those subjects. So you need to bring all those expertise together and then come up with a solution for a particular coastal area. Unless until you share the data, you bring them together in a common table, take out the plan for the development of coastal zone, a coastal zone management suitable plan cannot be exercised. Now let us come to the coastal zone. So this is a remote sensing image of our coastal zone. If you see, it is our Indian coast. We have around 7,500 kilometer long coastal zone. So total length of the coastal zone, our Indian coastal zone is 7,500 kilometer. Where we can summarize that there will be east coast, there is the east coast, there is the west coast, there is Andaman Nicobar Island and Lakshadweep. And east coast, what are the characteristics? East coast we have a large fan-severed delta like Sundarban, Bhitarkanika, mangroves we have in Sundarban, Bhitarkanika, and Sundarban delta is the world's largest delta. We have a good amount of mangroves. Sundarban mangroves, 1/3 is in India, 2/3 is in Bangladesh. Bhitarkanika in the Odisha, Pichabaram in the Andhra. There is a saline lakes, Chilka, Pulicat. There is Gulf of Mannar. West coast, they have estuaries. There are creeks, backwaters. They have estuary like Narmada, Tapi, Mahi, Sabarmati in the Gulf of Khambat. We have a Gulf of Kutch. Various ports are there in the west coast. Limited coral reefs in the Gulf of Kutch, and also we have a good mangroves in the west coast as well. Andaman Nicobar, mainly we have corals over there, saline creeks, dense forest. Andaman Nicobar, Lakshadweeps are mainly coral island. We call them the atolls, and also we have a 14 marine in the coastal protected areas. So these are the major characteristics of Indian coast. And in this coast, there are various issues. If you want to manage a coastal zone management plan, if you want to develop a coastal zone management plan in a particular area of the Indian coast, our country, so there are various issues we need to address. So if we summarize all those issues, it has been seen the major issues are like first issue I can say is a population pressure, because we know now we are the world largest populous country. So lots of people living in the coastal area. So that population pressure itself is a major concern for the coastal resources in the Indian of our coastal area. And there are it has been seen that over the time the mangroves and the coral reef ecosystem are declining. There are various reasons. Not only all the reasons are anthropogenic. There are natural reasons. There may be a cyclone. There may be a tsunami. There are global warming is happening, which also anthropogenic activity, and also the cutting of mangroves, destruction of the coral reef because of the global warming. So because of the industrial affluence. So there are lots of reasons are there, both the natural and the man-made, which declining the mangroves and the coral reef ecosystem. Various places there are the municipal sewage and the waste water disposal we are doing. So all the disposal water we are dumping in the coastal area, industrial affluent, solid waste disposal. Because we think whatever the waste we are generating, let us put in the coastal area in the ocean, it will be being taken care by the ocean. But it usually it will never happen. So it creates a lot of degradation in the coastal water. That water goes along the coastal area through littoral drift, and it reaches very far off region and destroy the coral reef. Other parts also destroy the mangroves, mud flat, and all other things. There are lot of natural disasters where we don't have much control, but they create havoc in the coastal area, particularly east coast, highly affected by cyclone. Of late there is a tsunami, there are storm surges, there are coastal erosion, there are saltwater intrusion in the coastal aquifer. There are various disasters are there. There are, in the coastal area, impact of the aquaculture. No, by aquaculture gives you, we import those fishes. They grow very fast because we put lot of pesticides, and we earn lot of foreign exchange. But they have a lot of negative impact, aquaculture impact over the coastal area. So lots of coastal area are battered with coastal erosion. We lose land. There is also impact of ports are there. Ports are needed, but they have an impact in the coastal area. Coastal mining activity, construction, ingress of seawater, the potable water, groundwater water is being pushed back towards the land because of the global sea level rise, because of unwithdrawal exploitation of the groundwater near the coast. So they invite the saline water far deep inside the land. So which is called we call them as a saltwater intrusion or ingress of seawater. There is the impact of the power plant because of the dumping of the thermal waste. Impact of tourism, definitely all tourists are not wise. They litter the coastal area, they destroy mangroves, they destroy corals, leave the plastics. So they are already there in the coastal area. So when the coastal zone management activities is concerned, basically, so we talk about the first we have to see the collection of the data. Whenever we need to manage any coastal area, we need data. So we have to see what are the various kinds of data that are available in the coastal area, and we have to rank the data reliability, because what are the maps you will be collecting. You have to see the scale, source, age, from where they are coming. So you have to ranking the data reliability, and you have to keep it up to date. As I have told you already, that coastal zone is very dynamic. So the map which has been generated by 10 years ago is of no meaning when coastal area is concerned. That may be good with a lithological map or geological map, because they don't change so fast. But when coastal zone this is concerned, whatever the data you are using for the coastal zone management activity, they should be up to date. Okay. And also monitoring the inventory studies. So whatever the inventory you can do using remote sensing or other techniques, like how much mangroves are there, how much corals are there, what is the total area of the mudflat, how much is the area of the like dunes or sandy beaches. So they are called inventories. So you have to keep a eye of the inventory, whether the mangroves is declining or mangrove afforestation is happening or deforestation is happening. All those information is very much needed. After that, you have to generate the various kinds of thematic map using remote sensing data, or which will be substantiated with the field information, definitely. So the maps will be generated in the various scale based on your objective. There may be 1 is to 50,000, 1 is to 25,000. A small area, if you want to develop, that may be 1 is to 10,000 or 5,000 map. You can be generated. We call them the thematic map. That can be done with remote sensing data, high resolution data, or depending on your objective, that may be of medium resolution data as well. Now, also the coastal zone management activities depends, like if you support the management or planning activities in any coastal area by providing the necessary sufficient information, being a scientist, you are supporting the coastal zone management activities, because as I told you, you cannot do everything of your own, but only a small component of the coastal zone management activities if you are supporting with your knowledge as a researcher, as a scientist, that means you are supporting coastal zone management activity in any region. You are doing your duty. Also, you can support the for the the policy is being written in a particular area. The people who are writing the policies, sometimes they may not be able to understand any particular area, the concern, which may, like you do certain kind of modeling study, or you can make certain simulation or a scenario generation in future how coastal zone is going to behave. So those kinds of map you should give the policy makers, then they will understand how the future policy will be being made for a particular coastal area. Now, obviously, there are certain parameters which is very difficult to retrieve using satellite data. So you need to do certain kind of research for getting those parameters which will help the management and the planning problem in the specific region. So you need to do definitely certain kind of research, because everything you just cannot get from a remote sensing data. Something will come out of the model, something can be come out of the field information. So you need to incorporate you have to do certain kind of modeling activities, like classification of the remote sensing data, incorporating various field techniques, use of lot of instrument. So then definitely your management plan will be better. A certain image I will show you from satellite data, where you can see the mangrove degradation in the Kakinada coastal area in the Andhra, where you can see the red color is a mangrove patch, and this black color, they are the aquaculture practices, aquaculture field. So you can see the aquaculture has come cutting the mangroves. Mangroves come under the CRZ 1, Coastal Zone Regulation 1. As per the rule, you cannot cut mangroves. But things written, but it's not being followed everywhere. The example from satellite data, you can get an unbiased picture. You can see now what is happening in the Kolinga mangrove area, where mangrove has been cut and the aquaculture is being practiced. Same thing is happening. Yeah, this is the Kolinga mangrove. This is the image. This area I showed you. This is the Kolinga mangrove. This is the Kakinada speech. So here the mangroves have been cut and the aquaculture practice has been started. So this is a ship breaking yard in Alang in the Gujarat coast. You can see the change in the watercolor, because they use a lot of oxyacetylene and other things, where the lots of iron dust and other things they are mixing in the coastal water, and along the Alang the water goes along the shoal line, which we call as a along with the littoral drift through the by the littoral current. It goes far of distance from the Alang and pollute the coastal water that side also. You can see, simply seeing the from the satellite image. This is the Google image, where you can see all these ships. These are the ships. They have come only for the breaking purpose for the various countries. So Alang, the area is that way. The water is getting polluted in the Alang area, because ship breaking itself is it's a though profitable business, but when coastal ecology is concerned, it is not good. So, but as we know that when coastal zone is concerned, everybody is interested to know about the depth, because bathymetry is very important for the various reason. Because until you know the bathymetry, you don't know the how big ship can come to a port or the harbor. Because basically it is a general practice that big ships should come till the harbor, so that you can unload the materials which is being bought by the big ships, and you can easily carry them through the road. But if the depth is not enough, then the big ship will be anchored far off from the harbor or the port. Then small ships has to go, which we call the barges. They will go, they will unload the material, bring to the port. They are all, lots of money will be involved. So you need to know the depth. If depth is sufficient is not there, sometimes we call you have to do the dredging. Dredging is highly capital intensive. Lot of money is required for dredging to increase the navigational depth. So satellite data has certain role to play with, because every time using echo sounding and other instrument, it's not easy to get the depth. I mean to say that it's cost effective and also manpower, other things. But satellite data, which is covers a huge area, there are certain algorithms are available, and it is quite no scientific. You can get at least first an idea about the what is the depth, quantitative analysis of the depth. So because whatever the bands, like remote sensing, we have a blue, we have a green, we have a red, we have NIR, SWIR, TIR. So all bands have different capability to penetrate the water. Red light attenuates rapidly in the water. So it absorbs water very fast and doesn't penetrate deeper than 5 meters. So using red light, you cannot get any information more than 5 meters. Blue light penetrates up to 15 meters. In clear water up to 30 meters. So in clear water, you can get information about the depth up to 30 meters using blue light. Green light penetrates as far as 15 meters in clear water around the coral reefs. I told you earlier that wherever that there are corals, the water is very clear. So in those places, green light can go up to even 15 meters. Near infrared penetrate maximum depth of 0.5 meter, and IR is the fully absorbed. So NIR band and IR band doesn't have any penetration capability, but it is important to understand, like NIR will be absorbed by the water. So if I want to find out the land and water boundary, if I load NIR band, what will happen? The water it will get absorbed. So the water pixel will be value of like not 0, but maybe within 10, or like 5, 10, like this black. But in the land part, NIR will be reflected. So the pixel value will be 100, 90, 150, 200, like this. So I can get a better picture about the land and water boundary. So NIR band is very important to understand land water boundary or aerial estimation of the inland water bodies. So they are very important. So all the bands are that way. It has its own characteristics. Now, if you see the status of utilization of the remote sensing data for coastal studies, I have summarized like when their utilization is concerned in a table where the left hand side is table where it is given the what are the parameters I am going to retrieve, what are the remote sensing compliances in the middle, and what are the present status, where you stand. Like when mangrove, coral reef, like salt pans, aquaculture, wetland, sandy beaches, dunes, those kinds of land use land cover is concerned, like remote sensing compliances like mapping and monitoring in the different scale, we can do it. And status is that they are operational using high resolution multi-spectral sensor from the IIRS series and other foreign satellite like Spot, Landsat, TM, ETM, OLI and other things, Sentinel. Okay. So they are operational, there is no doubt. When fishery is concerned, fishery forecasting and the monitoring, PFZ we call it, they are semi-operational using NOAA which from where we get the SST, and the IRS P4, P6 where I get the chlorophyll concentration. It is semi-operational. The word is it has been used because the getting the chlorophyll concentration in the coastal water is a very tricky business. There is no robust algorithm available where the same algorithm can be applied for any kind of coast in the coastal water, particularly where I will get the very accurate ocean color. It works fine in the open ocean. Things are very simply, that's why we call it the open ocean is optically simple, coastal water is optically very complex. So that is why it is written semi-operational. Like coastal geomorphology, shoreline changes, their mapping, monitoring, different scale is possible. It's operational. We can get information the sea surface temperature, wind, wave, water vapor. So they will be used mainly for the ocean monsoon study, ocean atmospheric study, fishery forecasting. So they are again operational with IRS P4 and other foreign satellite like as NOAA data, the wind data, like microwave sensor data, ERS data, GIRS. They will give you the other information regarding the waves and the winds. Also, remote sensing data can give you the to map the upwelling areas, the eddies and the gyres. They are very important because in this region, from the bottom, the water, cold water with lot of nutrients, they come and mix with the upper warm water. So those areas are good for the fish location because where the concentration of chlorophyll is high, so fishes will try and for their food in those regions. So they are important for the fishery study, and this circulation where from the bottom water is coming and missing, that will help you to understand the ocean dynamics. They are operational with the IRS P4. We can map the CRZ coastal regulation. I am coming in the subsequent slides. So entire Indian coast as a CRZ mapping has been done in 1:50,000 and also in selected places 1:25,000 scale. We get to know the suspended sediment concentration, we call the SSC. SSC study is possible using our ocean color sensor data, mapping, monitoring, IRS P4 and P6. Oil slick study, oil pollution, this is very important study when a coastal environment is concerned, but this study nicely can be done using microwave sensor data. Okay, our RI set data or GIRS or ERS data or Canadian radar set oil slick mapping can be done. Chlorophyll, as I told you already, the IRS P4, P6, and also we can study the current and the surface circulation pattern using various kinds of remote sensing data. So much of parameters can be retrieved from remote sensing to study the coastal zone. And when let us talk about little bit of the coastal hazard, because when we do the coastal management, it is not only the coastal resources, hazard is also one of the important component of the coastal management, where we need to know how to manage the coastal various kinds of hazard. So hazard can be classified in the coastal area in two. One is the short term and the long term. Short term hazard means so they will just come and go and will do really havoc in the coastal area. Long term are the chronic disasters. Short term means cyclone, hurricane, typhoon, tsunami, okay, flash flooding from the river. Long term, slowly it will chronic disease like land subsidence, sea level rise, coastal erosion. So it will eat up the coastal area slowly. Cyclone, it is an atmospheric closed circulation rotating counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Also, along with cyclone, there is another term we call the storm surge. Basically, storm surge is abnormal rise in the sea level accompanying a cyclone or the other intense storm, whose height is the difference between the observed level of sea surface and the level that would have been occurred in the absence of the cyclone. That is mainly the increase of the sea surface, increase of the level of the sea surface. Storm surge is usually estimated by subtracting the normal or atmospheric high tide from the observed storm tide. So that is the storm surge. Storm tide, there is another term called storm tide, which is the actual level of sea water resulting from the astronomical tide combined with the storm surge. Hurricane and the cyclone, basically typhoons and the hurricanes are the tropical resolving storms. They are called cyclone when they occur in the Indian Ocean. When they occur in the Atlantic Ocean or the Pacific Ocean, they will be called as the typhoons or the hurricanes. As I told that cyclone is basically a low pressure system or depression, and on which the air circulates anti-clockwise direction in the northern hemisphere, clockwise direction in the southern hemisphere. The speed of the circulating air masses exceeds 33 meters per second near the Earth's surface, and there are a lot of scale of the cyclone given by the Indian Meteorological Department, when it will be called a depression, whether it will be called a cyclone, deep depression, super cyclone. Those terminologies are there. You can always get to know if you visit the IMD site. So when there is a cyclone, there is a strong wind associated with it. There is a storm surge at the local sea level rise, and there will be heavy rain. And when there is a strong wind, that caused damage to the structures, buildings and other things, and also strong wind caused the destruction of the crops. Storm surge and sea level rise, they call the flooding in the neighboring region, and also heavy rain causing the flooding. Flooding basically caused the loss of life, and also flooding caused the destruction of the crop. Damage to the houses, building also caused the loss of life. So that means you can see a single disasters or hazards, tropical cyclone, they are causing so many disasters together. There will be loss of life, there will be damage to structure, there will be flooding, there will be destruction of crops. Everything is happening out of a cyclone only. So you can see this is the image of the cyclone movement of the inset image of the super cyclone of the Odisha. You can see how the cyclone eye is getting movement, and then finally it is rotating along the coastal Odisha and creates havoc in the coastal Odisha during the during the time 28th October to 30th October 1999. Basically there was a prediction, that time prediction was not very accurate. So the prediction was that it will hit the Odisha coast, then it will go along the Odisha coast, and finally through West Bengal it will end up in the Bangladesh. But sometimes nature is very difficult to predict nature. It didn't go to West Bengal and Bangladesh, so it remained in the Odisha coast for 3 days, and that is why it got the status of the super cyclone, and it creates lot of destruction in the coastal Odisha. You can see some of the field photographs during those days, how things have been affected the super cyclone. So some image analysis that time was done with the coastal Odisha by the Odisha Remote Sensing Center, Bhubaneswar. So basically pre-cyclone and the post-cyclone image, because of the cyclone there will be lot of destruction of the coastal vegetation. So there is an index called NDVI, normalized difference vegetation index, which is called IR minus R by IR plus R. Its values ranges -1 to +1. If the values are towards the positive +1, that means health of the vegetation is good. Water is a negative, or if the values are 0.2, 0.3, that means also health condition of the vegetation is deteriorating. So you can see here in the pre-cyclone image of the some part of the coastal Odisha, this is the WIPS data, pre-cyclone 11th October data 1999, where the NDVI image has been developed. You can see there the Bhitarkanika mangroves. Okay, this is the Gairmatha beach, where the mangroves the values are positive value. This is the values are basically in point, but it has been multiplied by 10 to get the whole number. So the values representing 5, 6, that the healthy vegetation. So whatever you can see the coastal vegetation, the values are mainly 5, 6, 4 like this. Health of the vegetation is very good. But after the cyclone, if you see, when you get the same WIPS data on 14 November, you can see here all the areas where the values were 5 or 6, they have been reduced to 2 and 3. You can see even all the mangrove forest also, you can see here the entire mangrove patch values 6, they have been reduced to values 5. Here all the coastal vegetation, their values are 5, they are healthy vegetation, but because of the destruction, some will be under the water, all the values will come down to in 2 and 3. That means there are a lot of vegetation effect has been happened because of the cyclone. At this study we can easily find it out using NDVI, and there are also a lot of other vegetation indexes you can study, and you can find it out that how much this type of maps basically the decision makers lead, or the need, or the administrator, they usually need this type of map to understand how much vegetation has been lost, how much paddy field has been lost, so that they can do the proper remedial study, what can be done in this region. So these are the very important component of the remote sensing data which can help you the decision makers to take the proper action. Now this is another term very important, coastal regulation zone. This is also again towards the coastal zone management. This is the regulation zone of the first regulation zone of the year 1991, where MOES Ministry of MOEF Ministry of Environment and Forest, they come up with a regulation for regulating the development activities on the coast. So the coastal stretches within 500 meters of the high tide are classified into 4 coastal zones. So basically CRZ boundary we call it, from the high tide line 500 meters towards the land, that entire area and the area between high tide and low tide will be termed as a coastal regulation zone, which can be divided into 4 parts: CRZ 1, 2, 3 and 4. CRZ 1 basically we call the ecologically sensitive areas and the area between high tide and low tide where no construction is permitted. And CRZ 1 all those ecologically sensitive elements like mangroves, coral reefs, sandy beaches, mud flat, sandy dunes, they will all come under the CRZ 1. CRZ 2 are basically the areas which already developed very close to the soil line, they will come under the CRZ 2. So before the regulations come, the areas, coastal towns, they are already developed. Okay, now we cannot destroy them. So there will be certain regulations which are permissible and the prohibited in the CRZ 2. So CRZ 3 like coastal villages, okay, readily undisturbed areas, coastal hamlets, small villages. So they will be CRZ 3. CRZ 4, special status has been given to Andaman Nicobar, Lakshadweep and other small islands. They will be coming under CRZ 4. And if you see the Government of India Rajpatra, the Gazetteer of India, there are lots of activities in the tabular format is given which is permissible, which is prohibited. So this type of activities are permissible in the coastal area and this type of activities are not permitted. But it has been seen of late that in the various different state, these activities are not regularly followed. Okay, the regulation zone itself is not being followed because we have a federal structure. Sometimes the different state they come out with their reasonment that I cannot leave the 500 meter from the high tide line, so that I will be left with no coastal zone. So what I will develop? So it has been seen of late that industrial growth, only few bullets I have shown you. There are n number of bullets where it has been seen that the norms of the CRZ has been flouted in our country. Industrial growth in Gujarat has damaged the CRZ 1 in the Gulf of Khambat and the Saurashtra. Mudflat in Maharashtra and Kerala reclaimed for agriculture, industrial, residential and aquaculture use. Salt harvesting and aquaculture development are responsible for damaging the mangroves of Tamil Nadu, the Godavari, Krishna regions and the Sundarbans. Mangroves have been cleared for the harbour activities near the Paradip port. So few examples I am just showing you. Even from remote sensing data, multi-temporal satellite data, it is very clearly you can find it out. This region where earlier it was mangrove, now for setting up a port, entire mangrove has been cleared up. Some area mud flat, it has been declared from some industrial activities. So for aquaculture activities, so things can be seen very easily. That means the regulation zone norms have been not followed. After that also, Government of India set up another committee by recently led our Professor Saminathan committee, then the last committee by Dr. Soilesh Naik committee for mainly for the coastal regulation zone. Now things are very happening because it's a very complicated area. So you need to take advice from the local stakeholders, the NGOs, local government. You have to bring them together, then finally this type of regulation can come up. So things are happening, but in a slow pace, I will say. So this is what, using remote sensing data we have mapped the Indian coastal zone. Particularly this is a very simple, like if I know the high tide line, like this can be, we can get it from like National Hydrography Office at Dehradun and the other places, the high tide line boundary. And from the high tide line you can see 500 meter. This is the Goa area, Panaji area. So 500 meter buffer has been developed. This is basically CRZ boundary. So I get the CRZ boundary. Once I get the CRZ boundary, I can classify all the areas, like supervised classification I can do, where there are the sandy beaches, where there is the industry, where there are the mud flats, where there are the mangroves. So accordingly 1, 2, 3 and 4 can be mapped. So this using remote sensing data, mapping of the CRZ has been done in the national level scale by Space Application Center at Ahmedabad in 1:50,000 scale, and few places where it is, requirement is there, it has been mapped in 1:25,000 scale. Now maybe high scale map 1:10,000 map can also be generative requirements come. Now let us talk about a little bit of the GIS. Basically, though in a coastal zone, GIS has not been extensively used like in other land areas. Most coastal data and information is spatial. Um, and as we know, the GIS in integrated coastal zone management makes sense for, like as I told you, for coastal zone management, lots of data you require, lots of integration of the data, and GIS is one of the important platform where there are certain techniques where you can integrate or analyze it large in the Richard database. Quality control of the data and information product, like you can see the quality of the data, like no the data redundancy, some outliers that can be removed from the data set. So those things you can manage using GIS platform. You can also do certain kinds of modeling and the simulation of the coastal processes using GIS study. Some scenario development you can do certain testings, simulator study. Like if there is a sea level rise of few centimeter, what of the area is going to be inundated. Then you can go even few meters, what of the areas is going to be inundated. Those kinds of scenario development you can do using some GIS software. Scenario testing for management options. Now those kind of scenario can be given to the management people, so they can accordingly take the decision. mm, Decision support very important in a GIS platform. Rapid response to the disaster, where to reach the at the particular time for the disaster, where to drop the relief materials, where everywhere GIS is important you can support. And also communication and sharing the ideas and the viewpoints. You can see this is like how the in a GIS shift on the different layer works. Here you can see the in the top there is a satellite data, like let us see the ocean color image, the ocean current, the vector data, bathymetry, gridded data. And then, there will be the coordinate measurement, station measurement, some particular point data you can see, and some particular parameter you have noted using certain instrument, seafloor maps. So all the maps, all the layers can be put together, and certain queries can be generated, and you can get better analysis in a coastal environment using GIS. And as you know, that this is the benefit of the coastal management. It's not for the. I feel it's not only for the coastal management. This benefits of GIS is for all the field, like ability to integrate data of the various types from different sources, enhance capacity of data exchange among the various disciplines, ability to process and analyze data more effectively and efficiently, ability to model, test, and compare alternative scenario in the real world system. That's what I was just discussing. Facility to efficient updating of the data in a GIS platform. Once data in a particular platform, you can go on updating the data. Wherever you get the data, you can upload and replace the old data. Ability to handle large data volumes in different format. GIS has the capability to do that. And but coastal GIS has many challenges, not like a land GIS, working with the three spatial dimensions X, Y, and Z, and along the Z, various parameters changes with time. Particularly, it is a like 3.5D GIS. We call that like even 4D GIS, working with the temporal data, because things changes very fast with time. So you have to incorporate time in the GIS. That really is a challenge. Working with the temporal data and the dynamic processes, great differences in the spatial and the temporal scale. Boundary is very fuzzy. Coastal boundary, as you know, there is a high tide, there is a low tide. Boundary itself is a fuzzy. That has to be represented in a GIS platform. Difficulties to defining object. Lack of also the specific coastal data model. So that's very important, which is a skeleton of a GIS system. People are working in the coastal data model. I know various labs in US and other places they're working how a data model concept can be developed for the coastal zone, where all kinds of spatial data, non-spatial data, raster, vector data from various platforms can come from the coastal zone, and they can be integrated in a data model format. We call the coastal database management system. So coastal GIS presents many various challenges. It's not a very mature technology. Coastal GIS particularly. GIS is a mature technology, because coastal GIS is not a mature technology. It's a support from the commercial sector, slow but slow to emerge, but growing. But because there is a less support for the commercial sector for the coastal GIS as such. And coastal managers and the scientists are not yet a major lobbying group in the GIS industry. So if you see the GIS industry, if you see the magazines or other, if you see GIS industry, lots of applications are mainly in the land-based application. And now in a GIS, in a traffic control, in the police department, in the crime world, everywhere GIS is there. So as such, in that way, in the coastal zone, GIS has not grown, because in the coastal zone the issue is that access of the data, all the data coastal area is sensitive. So data, there is a security concern, data we cannot get data very easily. There is a cost issue, data is expensive, and also time series data. As I told you, it is not a one time data. You gather the data, you think things are over, like geology, geomorphology, soil, land use. No, So there is a time series data is required, and if data is available, are they in a suitable form? If data you are getting the data, are they are in the form? So that's they are the various issues, particularly security, sensitivity, cost. These are the issues. So I will just show you rapidly few case study which has been done in IIRS by various students and our departmental case studies. So like some study has been done by my MTech students using erosion accretion along the Kakinada coast. You can see this is a Kakinada speed where the areas where erosion has been happened, where accretion has been happened has been shown using multi-temporal satellite data and the survey of India toposit. Like this here the image which we have used of the 1999 image, and SY toposit has been used of the 1974. So scenario of the last 25 years has been developed particularly to understand which part of the speed is eroding, which parts of the speed is deportating, and consequently the remedial measures like how to control the erosion of the speed, what are the remedial measures, what are the engineering measures can be taken up, that can be thought of. Also soul line changes of the one of the area where multi-temporal satellite data can be used. Like here you can see in the Gulf of Khambat, this type of area, this type of study can be done, where the red line is the soul line of 2003 and blue line is the soul line of the 1970. So you can see which part is getting eroded, which part is getting deposited. Nowadays quantitative analysis is possible, like nowadays there is a DISA software which GIS extension. Using those software you can find out the like linear regression rate, net sediment movement, those kinds of techniques are there in the DISA, so we can find it out which part is eroding more, what is the rate of the erosion, what is the rate of deposition, and also at the same time you can do the future prediction of the soul line, how the soul line is going to be there in that particular region in the year of 2050 or 2030. We can do those kinds of analysis. Also, the study can be made for saltwater intrusion along the coastal Gulf of Khambat. One study has been made to see how the saltwater intrusion is affecting, particularly when the health of the people are concerned in the Bhavnagar coastal area, where mainly the saltwater intrusion is happening because of the unscientific ways of withdrawal the groundwater near the coast for making the salt farms. Gujarat is the highest producing salt in our country. So these are you can see these are the salt farms where the people supposed to get the water through the creek during only the high tide time. Okay, but our in a coastal system we have a semi-diurnal tide. So if there is a morning 6 o'clock high tide, evening 6 o'clock there will be next high tide. So if you miss the morning high tide time, you couldn't collect the water, then you have to wait for 12 hours. So by that time, that day business is gone. There will be no sunrise after 6 o'clock or something. So people what they do, they usually where the groundwater, local ground, where the very near to the coast is highly saline. So they pumping the groundwater without understanding the consequences, subsurface geological, the mechanism, and the groundwater, and more the withdrawal of the groundwater they are doing, more they are inviting the saline water interface to move towards the land. That is what it is happening. You can see the various contours, the color has been generated, where as per the standard given by the WHO or European Union, they are telling that you should not drink more than 250 mg per liter the chlorinity content of your water. So if you go on drinking chlorinity content of water more than 250 mg per liter for a long run, you're supposed to be affected with various kinds of diseases. But here you see we collected water sample from the various talabs along the villages like Alang, Sisodia, Goga, Gundi, Bhavnagar, like tube well, where the people usually drink the water from those sources, and analyzed in the local chemistry department in Bhavnagar University, and draw the contours. Then it has been seen the green line where the chlorinity content is 250 mg per liter. It is going away like around 25-30 km higher from the coast, and near the coast you can see the violet line chlorinity is 1000 mg per liter, 750, 500. So this entire region, what are the village you can see over here, with a sizable amount of population, they are drinking water which is having the chlorinity content is very high. Okay. So we did certain kind of modeling study to understand in the pre-monsoon and the post-monsoon study. So they are the all oil locations, and we get all the oil location data, particularly subsurface data, various kinds of like total depth, static water level, total dissolved solid, TDS, carbonate, bicarbonate, chloride. And in Bhavnagar district, the data being provided by the Gujarat Water Resources Development Corporation, Gandhinagar, and this data has been collected from the year 1983 to 2003, every 5 years interval, pre-monsoon data and the post-monsoon data. May and October, because when there will be lot of showers during the monsoon period, the scenario will be changed of the saline water intrusion during October. Okay, so if you want to do this type of study, definitely you should do it in a different season in the same year, both pre and the post monsoon. So these are the all vulnerability ranking using a model called semi-empirical Galdit model. We use that model to try to understand this side is the ocean. So along very near to the coast, there you can see in a pre-monsoon season. So these are all red area highly vulnerable. Then there are the moderately vulnerable, less vulnerable, and few areas which are not vulnerable based on the subsurface geological, geohydrological conditions. Now, when the same data we collected and run the model for October, okay, that's the post monsoon, you can see now only the highly vulnerable region is restricted only few pockets. So these area inter-region areas are moderately vulnerable, less vulnerable area has also increased, and also at the same time few areas which were earlier the less vulnerable, they have come as a non-vulnerable region. So that means pre-monsoon and post-monsoon scenario is different. If you want to do this type of study, definitely you should do it in a different season. And after that, we tried to put the village locations over those contours on this region which are more than 250 mg per liter, both pre and post monsoon. So this is all affected villages, dotted line you can see, post monsoon and pre monsoon. And also then we calculated, we know the all the population of the village. Then we tried to find out how much population is affected in the pre monsoon, more than 250 mg per liter chlorinity, how much population is affected post monsoon, more than 250 mg per liter. So those calculations are available. Also this type of study can be done. You can do this type of work also for storm surge risk generation along the Orissa coast. Like if you have a good resolution digital elevation model, then you can find it out if there is a storm surge, there is a local sea level rise of few centimeter. So what are the areas which will be high risk, medium risk, and the low risk zone? We can find it out based on there. Like particularly inundation will happen in the areas which are the height is very less. Okay, so those areas will be highly inundation prone. So during cyclone tsunami, we need to leave those areas. Based on this concept, you can find out the areas of the cyclone center. In the Odisha, there are various regions. We have found that lot of cyclone centers have come up. So there are few basic criteria for getting those cyclone center. So those areas we have found it out that this is the area where we can make for the future cyclone center. Another important study for the using the remote sensing in the potential fishing zone. Okay, so those areas, as the name itself suggests, potential fishing zone is means the areas where chances of getting fish are more. So this is the area, the upwelling, the eddies zone particularly, but of late it has been seen when we get to know the chlorophyll concentration, the areas where chlorophyll concentration is high, suitable temperature, particularly SST and the chlorophyll, they are the two important parameters which will tell you the areas for the potential fishing zone. You can see this is the map of the Bay of Bengal region from the NOAA SST map on 23rd April 2001. So this is a concentric ring, this is the eddy structure. You can see this is the temperature, where this is the low temperature, this is biased to 25 degree, and this side is the high temperature here. So here this is the concentric rings are there. So this is the eddy structure. So here basically from this image itself, it can be seen that this area are suitable for the PFZ. Now when I getting the same date, the chlorophyll map. So this is the chlorophyll map IIRS P4 on 23rd April 2001. So you can see the phytoplankton concentration. You can see from the ocean the sediments have been marked, the high SSC. After that you can see that from near the coastal zone, as I told you earlier, the concentration is high. When I go away from the coast, the chlorophyll concentration is decreasing. And whenever I am superimposing one above the other to get the potential fishing zone of 23rd April 2001, we can see that it perfectly matches in the eddy zone particularly, which is the high PFZ area, then medium PFZ area, low PFZ area. So this way we can get to know the various PFZ potential, and these type of techniques initially developed by the Space Application Center and National Remote Sensing Center. Then after the TOT, with transfer of technology, the entire techniques have been given by NQuest at Hyderabad. Now operationally they are giving any fisherman now going to catch the fish, they go with the PFZ map and the GPS, so they know where I have to catch the fish. So it has been seen of late that their economic condition has been improved quite a lot, their profit has been increased. So earlier it was mainly by the luck, they don't know whether they will get fish or not, but now the scenario is not like this. The last year I will tell you that there is a study has been done because of the last tsunami which happened in our country. So that tsunami study has been done You can see this is the pre and the post tsunami image of the Banda Aceh region, Indonesia. This is a pre and this is a post. So after the tsunami, entire thing has been devastated. This is the Marina Beach. This is 12 January 2004. That came 26 December 2003. So this is the 2004 and this is the 26th December 2004 the tsunami came. This is the image of the 27th December 2004. You can see the earlier before the tsunami came, it was a very pristine white beaches, Marina Beach. You can see after that the entire Marina, half of the Marina Beach is waterlogged. Okay, waterlogged is the top of the this is water, and you can see there are certain temples. The entire temples have been devastated. New creeks have been developed. Here there was no creek. Now you can see new creek. It's a lots of images available of the Andaman Nicobar and those areas during those days from National Remote Sensing Center website. So you can see some big island. They have been broken into two parts. Now Indira point below the water. So those things are happening. Certainly, remote sensing data is also very helpful for finding out the inundation due to tsunami. Penetration of water body because of the tsunami towards the land can be easily traced from the suitable remote sensing data. So we get to know that how much water has penetrated inside the land. From remote sensing data, you can find it out. This inundation line derived from the ground survey can be superimposed over the taluk or the village map using GIS to have an idea about the affected agriculture area, human population, and the infrastructure. Once I know how much inundation has happened, and if I can superimpose all the taluk and the village and know the population, I will be able to tell this much of population are under distress. So if I know that this much of population, then I can tell the people or the decision makers can take a decision how much relief operation is to be required, how much relief material has to be put through helicopter and other means. So these are very important during disaster time. So this type of map has been generated during those days. So this is the tsunami inundation map around Nagapattanam area in Tamil Nadu. So this map they supplied immediately. This is by ICMEM PD, at that time Department of Ocean Development. They said this map given to Ministry of Home Affairs so that they get to know what are the see all the hatch line, the blue line. These are the inundation region, and this is not a straight line because how much water will go deep inside the land, that also depends on various parameters. That depends on the earthquake parameter, nearshore bathymetry, beach profile, land topography, velocity of the tsunami waves, and the frequency. Due to this parametric variation, the inundation varied from one location to the other location. Thank you very much.